How would you send a message that literally no one else could see? It's a question that has been at the heart of espionage for centuries, turning something as simple as a letter into a powerful weapon. And secrets, well, secrets, into survival. Okay, picture this. It's World War II. You're an agent, deep behind enemy lines. A hidden message isn't just some cool spy trick. It's your lifeline. The British Special Operations Executive, the SOE, they had this training manual that was brutally clear about what made the perfect invisible ink. I mean, look at this list. It had to be perfect. Getting even one of these things wrong could be the difference between a mission's success and, well, never making it home.
So first up, let's dive into that classic spy's secret weapon, the long, and you'll see, surprisingly creative history of invisible ink. Now, this idea of secret writing has been a game changer in conflicts for ages, but it really came into its own during wartime. I mean, George Washington's spies used it to outsmart the British. In World War I, German agents famously became known as the lemon juice spies. But by World War II, the chemistry got even more clever. Allied agents were using something called phenolphthalein, a chemical they could get from, of all things, laxative pills. Talk about the perfect disguise, hiding a secret weapon right there in an ordinary medicine cabinet. So how does this so-called magic actually work? Well, it's not magic at all. It's just some beautifully simple chemistry. Let's break down that classic lemon juice trick. When you write with it, you're not really adding anything. You're changing the paper itself. The acid in the juice starts to weaken the paper's fibers as it dries, and that is the secret. So when you apply heat, those weakened, acid-treated fibers simply burn or oxidize way faster than the rest of the paper. They turn brown, and boom, just like that, your hidden message appears. But here's the crucial part. Spies didn't just rely on one method. Oh no, they had a whole toolkit. You had your heat-activated inks, like lemon juice or even milk. Then you had others that needed a specific chemical reaction, like that phenolphthalein we mentioned, which turns pink when you expose it to ammonia. And some would only show up under the glow of a UV light. Every single secret message needed its own special key to be unlocked.
So that covers the spycraft. Pretty cool stuff. But here's a wild thought. What if you didn't need a pen or a chemical? What if your own body was sending out invisible messages all the time? All right, so now we're going to shift gears. We're moving from the world of espionage right into biology to explore the secret messages that we are all sending without even realizing it. This biological secret messaging system actually has a name. It's called chemosignaling. Really, it's just a way for living things, including us, to communicate using chemical cues. And our main way of sending these signals? Body odor, which it turns out is way more complex than you probably think. To really get this, we need to decode our body's own invisible ink, sweat. Because as it turns out, not all sweat is created equal. Your body's basically writing two very different kinds of messages. Okay, so here's the key difference. You've got eccrine glands all over your body, and they produce that watery sweat that cools you down. Think of it as hot sweat. But then in your armpits and other areas, you have apocrine glands. They produce a much richer, oilier sweat. And they're not activated by heat. They're activated by emotion, stress, fear, anxiety. This cold sweat, that's the body's invisible ink. Now, here is a critical point that almost everyone gets wrong. Sweat itself is odorless. Seriously, even that emotional apocrine sweat has no smell when it comes out. The message isn't the sweat itself. It's what happens next. The scent we call body odor is actually created when the bacteria on our skin start to feast on that rich cocktail of proteins and fats. In other words, the bacteria are the developer fluid that reveals the hidden message. This whole interaction, your emotions, your glands, your unique skin bacteria, it creates a scent signature that is totally unique to every single person. It's like a chemical fingerprint, a personal sweat print. And this sweat print of yours is unbelievably complex. It's shaped by your genetics, of course, but also by what you ate for lunch, your health, and even your psychological state. I mean, studies have shown that fear and happiness can produce chemically distinct sweat signatures. There was even one study that found men with higher self-esteem were rated as having a more pleasant body odor. It's wild. And get this, a single gene called ABCC11 plays a massive role here. If you have the functional version, your skin tends to host more of a bacteria called Corneobacterium, which can lead to more intense odors. But if you have the inactive version, your skin favors Staphylococcus bacteria, which results in more neutral smells. It's a perfect example of how our deep-seated genetics are directly shaping the invisible messages we send out every single day.
All right, so let's bring these two secret worlds back together now.
the spy's ink and our body's own biological signals.
The parallels here are pretty striking when you think about it. A spy's message written in lemon juice is completely useless until someone applies heat. In the exact same way, the chemicals in your emotional sweat are just meaningless molecules until someone else's brain decodes them, often totally unconsciously, as fear or stress or happiness. They're both hidden messages, just waiting for the right developer to come along and reveal them.
And that really leaves us with one final thought. From the subtle pressure of a handshake to the invisible chemical signals floating in the air, communication is happening all around us on levels we barely even notice. So it makes you wonder, doesn't it? What secret messages are you sending, and what messages are you receiving without even realizing it?